And we now get to try the next one. Finding the global maximum and minimums of this function. It requires that we're feeling really good about our sines and our cosines. Let's take the derivative of this. G prime of x will be 2 times cosine of x. And then I have a negative cosine of 2x. The derivative of cosine is a negative sign. And don't forget that hook on. That chain rule says take the derivative of that 2x, which will be a 2. All right, so that can be simplified, and let me simplify that out. G prime of x will end up being 2 cosine of x plus 2 times sine of 2x. There we go. And I wanted to set that equal to 0 and try to solve it. And it's not as easy as you think, because it's going to require a trig substitution that you might not feel comfortable with. So this question is like just for the kids that are really trying to pass the AP exam with a 5, right? So what do they have memorized? What they have memorized is that the sine of 2x is, this is the double angle identity. I just put it onto our mega cheat sheet because so many of you are interested in these kinds of things. You're really trying to get that 5, and it's right there. It's the double angle identity. It's on the back side of the mega cheat sheet. Okay, double angle identity. 2 sine of theta, cosine of theta. We're multiplying all those things together. So here we come back to our problem, and I'll make that substitution now. So I'll say that this is 2 cosine of x plus 2. Instead of sine of 2x, I'm going to have 2 sine of sine of x and cosine of x. It threw me off for a second because remember, on the mega cheat sheet, they're using thetas. So I'm pretending that's an x, that's an x, that's an x. The 2 comes out in front, and a sine gets turned into a sine and a cosine. And how they derive that, that's for pre-calc. I'm not going over that right now. But we get to use it in calculus anytime we want to. That's a double angle identity, and we're using it right now. And why would we do that? Is that helping us in some way? When I look at this, is it making my life easier? Well, I mean, yes and no. What turns out is that there's a cosine that I can factor out, and that will help me separate these into 2 different terms that can be put together just a little bit better. In fact, while I'm at it, why don't I factor out this a 2 as well? Not that 2. Let me factor out that 2 right there. So let me see. I'm going to rewrite this as 2 times cosine of x. And what do I have left? I still have this 2 and this sine, and I factored all of that. So there's a 1, and there's a 2 and a sine of x. And those 2 things equal 0 now, and that's a little bit easier for me to solve for, because for this one, 2 cosine of x needs to equal 0. I divide by 2, and I just am looking now for when cosine of x equals 0, and I have the graph of cosine memorized. It looks like that, where this is 0 and this is 2 pi, and so that right there is pi, and that means that pi over 2 is where it's equal to 0, and 3 pi over 2 is where it's also equal to 0. So x can either be pi over 2 or 3 pi over 2. And the other side, I'll do 1 plus 2 sine of x equals 0. I'm going to minus 1 from both sides. So I'm going to get 2 sine of x equals negative 1. I'm going to divide by 2. And so I'm looking for places where sine of x equals negative 1/2. I have my unit circle memorized, sort of. And so I've been do a little refresher, double check, but I'm pretty sure that this 30-degree angle, the one that I really want to keep in my head for forever, the one that's the perfect one to help me with this, is that the x value will be square root of 3 over 2, and the y value will be 1/2. So square root of 3 over 2 and 1/2. And I'm saying that this is a cosine value and that's a sine value. So 1/2 is very close to where I want it to be. Maybe what I need to do is find the negative 30 degree. And this point then will be square root of 3 over 2, and I'll get that magical negative 1/2 that I wanted. Unfortunately for us, this is going to be pi over 6, and this is going to be negative pi over 6. Unfortunately for us, negative pi over 6 is not in the domain. The domain is from 0 to 2 pi. So I'll need to convert this by having 2 pi take away that pi over 6. That leads me around in this direction to get to this terminal angle, and that will end up being, take away a pi over 6 away from 12 pi's over 6, you end up with 11 pi's over 6. But that's not the only angle where it will be negative. It will also be negative over here, because this is also a negative 30 degree angle. And so this point right here would be a negative square root of 3 over 2 and a negative 1/2. And so how do I calculate that? Well, that's a pi, and then I want to add from that pi, that 1 pi, I want to add another pi over 6. So this is 1 and 1/6 pi's. So if I say I had 6 over 6 pi's and I add another pi over 6, I'm going to end up with 7 pi's over 6. So my values that I'm interested in are going to be pi over 2, 3 pi over 2. They're going to be 7 pi over 6 and 11 pi over 6. So now that we have these critical numbers, we go ahead and evaluate the function at each of these critical numbers and see what our height will be for each of them. So x, g of x, I have all these critical numbers I want to work with. For example, the beginning of the interval, the end of the interval, and everything in between. So I've got the pi over 2, I have the 7 pi over 6, and the 3 pi over 2, and the 11 pi over 6, and then here I'll put the 2 pi. And so I've written my function right here, 2 sine of x minus cosine of 2x, and I'll leave it to you to do the rest of these, but I'll just do the first one for you, cosine of 2 times 0. I've got sine of 0, which, unit circle, have you got it memorized? This point is 1 comma 0. That is cosine, that's sine. And so I say that sine of 0 is 0. And so I have 2 times 0, and then I'll do cosine of 0, which will be 1. So I'm going to minus 1, and 2 times 0 minus 1 ends up being a negative 1. And so you can see how that is. Now, just as far as my lecture notes go, I've got this 2 plus 1, that's the sine, that's the cosine, ends up being 3. I've got the cosine and the sine. I've got the cosine and the sine, and then I've got the cosine and the sine, and the last one here. Boom. So I'm taking a look at all these values, and I'm seeing like the highest high I have is that 3, and the lowest low that I have is that negative 3/2. And so my answer is going to be there as a max at x equals pi over 2, and the specific point then would be pi over 2 comma 3. And then I have a min, actually I have 2 of them, 2 absolute mins, because they happen to have the same height. So you're allowed to have 2. How come I can't make that? I've forgotten how to make that. Okay, and then I get that is happening at 7 pi over 6 and at 11 pi over 6. and those specific heights would be 7 pi over 6 comma negative 1.5, and the other one be 11 pi over 6 and a negative 1.5.